anthropologists will point to other creatures that engage in art. But it's a kind of art that would only be put on display in a modern museum of art. I mean, you can get an elephant to swing a bucket of paint and put something on a canvas. Likewise, you can get chimpanzees doing that. But we notice in the certain caves in France, dating 33,000 years ago, you'll see murals of these animals being portrayed. And given the level of brush technology they had and pigment technology, the art they display is every bit as advanced as the art we are able to do today. In fact, as you look at the French and Spain cave art, and it spans from about 11,000 years ago to 33,000 years ago, we see zero evolution in the quality of the art. And when you compare it with modern art, again, taking into account that we have more technology today, again, we see no change. So there's another example that at the intellectual level, we're demonstrating zero evolutionary advance. Now, you might complain about the recency of these dates. How come these dates are coming in at 40,000 years ago when we have the calibration of the Bible, Genesis 11, coming in at 50,000 years ago? Well, this is explained by the fact that archaeological finds are only going to show up when you have a relatively large population. If the population is small, there will not be enough stuff produced to leave behind a long-lasting archaeological record. And so what we're documenting here is not the origin of humanity, but the origin of a large population of humanity. And therefore, 10,000 year separation is entirely within reason. But the biggest advance in human anthropology has been in using the mitochondrial DNA to try to develop a date and a location for the first man and the first woman. Now, the technique goes as follows. You sample people all over the world in different ethnic groups, and you measure the diversity in the mitochondrial DNA. And then you dig up people that have been dead for a measured period of time. And Japan's been a great place to do this because they have all these graves, and you can determine through carbon-14 how long that creature has been there. And they kept good care of the bodies so that you can get a faithful recovery of the DNA. And what that does for you is allows you to measure the rate of evolution in human mitochondrial DNA. Now, this technique allows you to determine whether the human species is descended from one or a few women or many women, and whether we're descended from a woman that comes from one region or many women from many different regions. And 3 and 4 years ago, there was a debate, and it's a debate that we portray in this book. It's the multi-regional hypothesis for the origin of humanity compared with the uni-regional hypothesis for the origin of humanity. Well, I'll just cut to the bottom line conclusion. Discoveries in the past 18 months have established that the multi-regional hypothesis is wrong. And once anthropologists figured out that Neanderthals can't be our ancestor, they looked at Homo erectus. And the thing about Homo erectus is that you can find Homo erecti finds in Africa, Europe, and Asia. So there was this idea that all the different races of humanity came from different subsets of the Homo erectus population. But mitochondrial DNA analysis on the human population proves that that hypothesis must be wrong, that the human species came from one region only. And also bears out the fact that humanity started off in one locale and then rapidly spread over the whole planet Earth. Now, you can also get a date for when this first woman lived. And the date comes in at 150,000 years ago. And it's got a rather large error bar, plus or minus 100,000 years. And that error bar has to do with the fact that it appears that mitochondrial DNA does not exclusively come from the mother. There's probably a tiny contribution coming from the father. And this is referred to as heteroplasmy. And in particular, they were able to dig up the Tsars of Russia. And they looked at about 4 generations of the Tsars, the most recent, and they could see heteroplasmy all the way through that line of the Tsars. And there's now some discussion to the fact that this is ubiquitous to the human population. And the bottom line there is that heteroplasmy would mean that you would divide the published date for mitochondrial DNA E by 3. And it gives you a date of 50,000 years ago. So we come from one place, one woman, or just a few women, dated around 50,000 years ago. And I think what's of some comfort to the Christian community, the scientific literature refers to this first woman as mitochondrial DNA E. They actually give it a biblical name. Well, we can do the same thing with Y chromosome.
Sorry, I just ask how these 150,000 years related to 50,000 years?
Okay. If you have no heteroplasmy, you get 150,000 years ago. If heteroplasmy is a significant factor, you divide the number by 3. And at least in that one case where we can actually determine or test whether or not there's heteroplasmy, namely the line of the SARS, we were able to see it in every single individual. So there's a growing consensus that we have to divide the number by 3. But I mean, if you read newspaper articles, they talk about mitochondrial DNA E living 150,000 years ago. So when you see those articles, just divide the number by 3.
And you're saying this evidence would be compatible with either 150,000 years or 50,000 years, but there is the additional evidence that you have to divide it by 3, so
right.
You're back to the original.
You're back to the original 50,000 year date. And what makes that especially compelling is that we can do analysis on the male side with the Y chromosomes. And again, this works similar to mitochondrial DNA. Y chromosomes are only shared by the males. Women don't have Y chromosome. So the only way my Y chromosome DNA can be different from my dad's is if I experience a natural mutation. But now we're working with nuclear DNA, not mitochondrial DNA. Heteroplasmy is not a factor in Y chromosome DNA. And because we're dealing with nuclear DNA, these kinds of genetic measurements have much greater precision. You know, notice with the Y chromosome, or the mitochondrial DNA, we're looking at a rather large error bar. But when you talk about Y chromosomes, we're looking at a small error bar. So the date that we're getting for the first man comes in at 42 to 54,000 years ago. Now, this is a date that I think legitimately you can compare with our best calibration of the Genesis genealogies. That's a fair comparison. And incidentally, non-Christian geneticists have made note of that approximate coincidence of dates, and they refer to this first man as the Y chromosome Adam. And also you get the same answer. The first man came from one location. And so this is referred to in the scientific literature as the Garden of Eden hypothesis. And incidentally, the Garden of Eden they've been able to locate. And what you'll see in the scientific literature is they've located the Garden of Eden as being Eastern Africa. But we argue in Who is Adam that that's entirely consistent with Northwest Mesopotamia, which I think is the best site from a biblical perspective for the origin of humanity. And the reason why they're saying Eastern Africa, this is where we see the greatest mitochondrial DNA and Y chromosome diversity in the human species. Africans have more diverse DNA than the rest of the peoples on the planet. And that's interesting in terms of this debate about the races, because all these people are black, and yet their DNA is much more diverse than, say, the DNA of Indians, Chinese, and whites. But I think there's another reason why we see such great diversity amongst the Africans compared to the rest of the peoples of the world, and that they practiced diversity in this sense. Most of you are probably familiar with that missionary annals of Stanley going into Central Africa. And what he discovered when he went into Central Africa were these black tribes living side by side, where one tribe would be exclusively pygmies, and yet just 2 or 3 miles away would be a tribe that was exclusively giants. And what we're talking is about one tribe being 3.5 feet tall on the average, with very little diversity in height, next to a tribe that was 7 feet tall on the average, again with very little diversity of height. And my point here is a point we make in this book, is that we need to take into account cultural